Thank you so much for joining our lesson. Remember to subscribe. Remember to share so that you may invite a friend. We are still projecting the Kcse 2025, and we invite you to this broadcast. Those who are new, please remember to subscribe. Shifting Grades is the home of academics. For those who have been around, feel much appreciated. We are wishing you success from the bottom of my heart. Ladies and gentlemen, I wish you success. It shall be well in the Kcse 2025. Give it your best and you shall succeed. So let us look at the section 2 of this paper. Remember, it's always good for you to choose your best 5 in the section 2. And as I've been advising people, take some good time to go through the 8 questions in section 2 before you choose your best 5. You might think 17 is very simple just because you've not seen number 24. You may think 18 is very good just because you've not seen number 23 and such. So let's go through all the questions so that people may know what to choose when the time comes. So make sure you make good choices depending on how easy it is to get the marks and how sure you are about whatever has been asked. Let's look at this wonderful program for the continuing students. If you are in secondary school or in junior school, we invite you to this powerful program. Kindly register for this. The timetable is out. We shall be occupying you from 9 to 1 p.m. But of course, because of the change of us from one lesson to another, because of the consultation process whereby students have to ask questions, we will have the lessons spilling over to slightly beyond 1 p.m. So please register. We have the details here, the registration details. Make sure you join us for the powerful interactive program. The junior school timetable is also out. Please make an appointment with us. Just organize. The number is already attached, 0704 15 33 66. Shifting Grades is the best program for you people. So kindly join. You'll be meeting a very serious team of qualified staff, teachers who know what they are doing, and they shall guide you through the program in the 5 weeks before we release you for the celebrations from 12th of December 2025. So kindly try Shifting Grades, please, and you shall not regret. 17, which is the first question in the section 2. The position vector of point A is 2, 4, and the vector AB is -6, -6. Find Roman 1 coordinates of M, the midpoint of AB. The midpoint of AB. Remember, we're not having the position of B already, but we are having the vector AB. It's good for you to know that. If you want to express vector AB, then you need the position of B minus the position of C. And with this understanding now, we can get the position of B, which is unknown. So the vector AB is already given. -6, -6 equals to vector B. Let me let it be. Minus vector A. The position of A is 2, 4, like that. So how shall you remain with A? To remain with A, you have to add 2 to -6, making it a -4. To remain with B, you're supposed to add 4 to the left to get -2. Therefore, the vector B, position of B, is -4, -2. Yeah? Let's check. Let's check now the next thing. If this is the position vector of B, and we are also having the position vector of A, then ladies and gentlemen, we can now conclude that the coordinate of A is 2, 4. The coordinate of A is 2, 4. Let me write it well. 2, 4. Then the position of B is -4, -2, -4, -2. So we are already having the coordinates, meaning that now to find the midpoint, and to remember generally, midpoints are given by x plus the second x. We take the average, comma, y plus the second y. We take the average. You see that? Therefore, for us to get the coordinates of M, then we need 2 plus a -4. We take average. 4 plus a -2. We take the average, giving us the coordinates of M as 2 plus -4 becomes -2. Out of 2, we get -1, comma. 4 plus -2, we get +2. We take the average, it becomes +1. Therefore, the coordinates of M, the midpoint of AB, is -1, +1. That is simply the coordinate. That is the simple statement of the coordinates. We can check now part 2 of the same question. We also told to find the distance of M from point R correct to 2dp. So we're supposed to find now another vector here, MR or RM. Any can work. The distance of R from M or M from R. So we need to take the position of R minus the position of M. Position of R is 5, 3. Position of M has just been calculated up there, -1, 1. We write the coordinate as a position vector now. So this position shall be 6 and 2, because 5 minus a -1 minus negative becomes positive. So 5 plus 1, 6, and 3 minus 1, that gives us 2. So there is what we call distance now, which will be magnitude. The magnitude of vector MR. Now this calls for 6 squared plus 2 squared. Then we take the square root. 6 squared plus 2 squared. We need a square root of 40. Remember, if it were not for the instructions on 2dp, you can even leave the answer as a simplified SAD. Yeah, you can leave it as a simplified SAD and you will get your marks. But now that we need it to 2dp, we have to simplify and have it as 6.32. So that is the length of the vector. You must ensure that you stick to special instructions like 2dp. Imagine working out all that, then you start missing just because you are not obeying instructions. Let's kindly obey instructions. Let's follow special instructions. Instructions about accuracies, instructions about, significant figures, decimal places, nearest whole number, and all that. The demand statements will always be accompanied by some coordinates, but by some serious instructions. Kindly, let's adhere to them. Don't just throw away marks. Please don't throw away your marks. Part B. Now, a translation T is equal to -1, -5. Maps point M onto P. Find the coordinates of P. All right. We're supposed to know one thing, that whenever we add a translation vector to the column vector of the object, we are supposed to get the image under that particular translation. Therefore, -1, -5. Now we're supposed to add the object, which is a point M, negative 1, 1, point M is here, negative 1, 1. This now is equal to, from the X coordinates, I'm having negative 1, giving me negative 2. Then negative 5 plus 1, giving me negative 4. So the coordinates of P now, negative 2, negative 4. That is the coordinates of P. At that point now, we can proceed to the last part of this question, Roman 1. Show that AB is parallel to PR. Show that AB is parallel to PR. Can we find vector PR? Because vector AB has already been given. Vector AB was provided in the initial instruction. Negative 6, negative 6. What about the other vector now, PR? You know, we need R minus P. The position of R is already stated in Roman 2 here, 5, 3. And the position of P has already been worked out here, negative 2, negative 4. Now, this is giving us 7, 7. Please confirm. 5 minus a negative 2. It becomes 5 plus 2, which is a positive 7. Yeah, very true. Then 3 minus a negative 4, it also makes it 3 plus 4. So the vector PR is 7, 7. Now with the two vectors already stated there, then we can confirm whether they are parallel to one another. We can confirm whether they are parallel to one another. For vectors to be parallel to one another, one should be a scalar multiple of the other. One should be a scalar multiple of the other. Therefore, we can say, if we take a constant multiplied by vector AB, is this giving us vector PR? Is it giving us vector PR? Let's check that. Is it giving us vector PR? So now from the numerator or from the X, you can see the value of K now shall be negative 7 over 6. And from the denominator, the same value is confirmed. Now, if it is confirmed that there is a scalar multiple that multiplies K to give us PR, a scalar multiple K that multiplies vector AB to give us vector PR, then we can conclude that vector PR is equal to negative 7 out of 6 vector AB, meaning that vector PR is parallel to AB. In case you express this, but you discover that according to X coordinates, you can get a certain constant, but when you get to the Y coordinates, you get a different one, then it would mean they are not parallel. But as long as the constant is proving itself to be multiplying the X and also to be the one multiplying the Y's to give you the other vector, then you are good to go. The two vectors are parallel to one another. Thank you. Thank you for following. Those who are joining us late, remember our line is 0704 15 33 66. Stay around until we predict even the paper 2. Yeah, until we project even the paper 2. Remember our serious programs here for the holiday. We are inviting all the continuing students in all levels. The high school, your timetable is ready. The registration details are already attached. For those in junior school, your brothers and sisters and siblings, your neighbors, invite them. Their timetable is also ready. Very clean work. Our designer ameweza hajaweza. Noma si noma. Please look at this very wonderful and great work. Remember to join our programs as we continue learning. Number 18. Number 18 is on equations of straight lines together with gradients. Now the equation of line L1 is already given there as 2x minus 3y equals to 12. Then a line L2 is perpendicular to L1 and meets L1 at a point where x equals to 3. Find, part 1, the equation of L2 in the form y equals to mx plus c, where m and c are constants. Okay, where m and c are constants. Now with this, there are a few things that we can compute just from the first statement and the second one. Line has been given. Another line is perpendicular to that. So with one equation, we can get equation of the other line, since we know how they are related, perpendicular to one another. Is that okay? Then if they are meeting at a point where x equals to 3, then we can now get this point as a full coordinate. By saying this first, this equation, we can have it as negative 3 y equals to negative 2x plus 12. So that will remain with y, we divide by negative 3. So this is becoming positive, but this is becoming negative when you divide through by a negative 3, meaning that the first gradient of L1 equals to 2/3. Now, we know that gradient 1 times gradient 2 should give us negative 1 when lines are perpendicular to one another. The product of their gradients should be a negative 1. And therefore, we can now say at this point, 2/3 times the second gradient should give us negative 1, meaning that to remain with the second gradient, we multiply both sides by 3/2. Yeah, we multiply both sides by 3/2, so that the second gradient now becomes negative 3/2. Very simple. Now we're having the second gradient, ladies and gentlemen. With this second gradient, something that you're supposed to know is that to proceed now to find the equation of L2, we are supposed to find at least a coordinate where it passes. So this line passes at a coordinate where x equals to 3. And we have the first line. So if x equals to 3, then what is y? If x equals to 3, what is y? Y equals to, according to the first equation, y equals to 2/3 into 3. 2/3 into 3 minus 4. So this value can be gotten. It shall be 2 minus 4. 2 minus 4, we get negative 2, meaning that the coordinate is 3, negative 2. Yeah, 3, negative 2. 3, negative 2. So we have now the coordinate established, because with an equation and either y or x coordinate, we can usually get the other coordinate, substitution method. Therefore, we are given already equation of a line. Then along this line, there is a point where x is 3. Then we can find corresponding value of y, which is now negative 2. With negative 2, we can write it as a coordinate now. Then we express now our gradient, negative 3/2 gradient equals to change in y minus a negative 2 minus negative 2. It becomes positive out of x, change in x minus 3. So across multiplication now will take us to, 2 multiplies everything. It multiplies y, and also it multiplies 2. At -3, the same. It multiplies x, and it also multiplies -3. -3 by -3 turns to a +9. How can we remain with 2y here? -3x, 9 minus 4, it becomes a +5. So how shall you remain with y? -3 out of 2, x plus 5/2 is 2.5. You see? So the equation is fully established. A very good question. This one is a very good question because apart from the perpendicular relation of the two lines, we are also supposed to know that by substitution method, we can get a coordinate which has not been stated. Is that clear? Look at the second equation. We also find a point on L2, which is equidistant from x and y axis. A point that is equidistant from x and y axis. Okay, that might sound, that might sound a bit unique, but it's a very simple question. A point on line 2, which is equidistant from both the x and the y axis. We're supposed to know one thing. There's something that we're supposed to know. I want to give you look at this sketch. Just look at this. According to this line, it behaves like this. Yeah, it is a negative gradient, and it also has 2.5 as the vertical axis. So L2 behaves like this. That's L2. Yeah, now if that is L2, there's something. This is L2. Now, points that are equidistant from both y-axis and x-axis, those points usually pass through the line y equals to x. This is line y equals to x. Line y equals to x. Yeah, because along line y equals to x, if it's a coordinate, you'll find a coordinate 0, 0, coordinate 2, 2, coordinate 3, 3, coordinate 4, 4, meaning that coordinates along this line are equidistant from x and y-axis. So if you pick any coordinate along here, if you pick a coordinate here, you discover that the distance it has from the y-axis and the distance it has from the x-axis is just the same distance. Therefore, it means that now at that point then, we just need to solve the two equations simultaneously because that is where they meet now. If a coordinate has to be equidistant from x and y, then it is on L2, it has to intersect with y equals to x. Therefore, we solve simultaneously, and where there is y, we can substitute with x. Like that. This becomes 2.5. Is it 2.5? Let's look at it. It's 1.5 already. It becomes positive 2.5 x equals to 2.5. The value of x is 1. The value of x is 1, positive 1. Meaning that now this coordinate shall be . this coordinate shall be coordinate 1, 1. Coordinate 1, 1. Is now the point which is equidistant from X and Y. Yeah. That is the point which is equidistant. Let's check part B. If X is 1, you can substitute 1 in any of the equations, either this or Y equals to X. That's why I'm getting coordinate 1, 1. So coordinate 1, 1 lies on that line, and it also lies on line Y equals to X. So it's equidistant from X and Y axis. Part B, another line, L3, is parallel to L1 and passes through -6, 5. Find the part 1 equation of L3 in the form, the form stated there, where A, B, and C are integers, not constants, integers. So if a line has to be parallel with another, the two lines have to share gradients then. So the gradient of L3 is 2/3. The gradient of L3 is 2/3. Meaning that because we have a coordinate where it passes, then we can find gradient. We can find equation. 2/3 equals to change in y, y minus 5, out of change in x, x minus a -6, making it +6. So we do a cross multiplication, but look at the format of the equation. It starts with x. So unlike the way I've been cross multiplying to start with the term with y, this time round I'm starting with 2x plus 12, because 2 multiplies everything, 3y minus 15. You see, after this point now, you can see everything is an integer. We don't have decimals, we don't have fractions. So I'm going now to arrange the equation to take the format stated up there. AX means we start with 2x. The term with B, -3y, equals to the constant now, -15 minus 12, making it a -27. Yeah, minus 15 minus 12, I think it's -27. So that is it, ladies and gentlemen. A very simple question. Very simple question about parallel lines. You're supposed to know that parallel lines share gradient. We can proceed to the last 3 marks of this question. Find the coordinates of the point where L3 and L2 intersect, meeting point of lines. We know that for you to find where the two lines meet, you just solve their equations simultaneously. So the first equation, you know, it's L2 and L3. So L2 is here. Y equals to -3/2. Y equals to -3 out of 2 x plus 2.5 plus 2.5, and then the other one is up here, 2x minus 3y equals to -27. So with this now, we can solve simultaneously. Remember from L2, the value of y has already been expressed. So we can substitute it directly now in equation 2, whereby we have to say 2x 2x minus 3 into 2x minus 3 into 2x minus 3 into instead of y, now we go back to the first line, which is -3 out of 2 x plus 2 and half. Then now this second equation equals to -27. So I've re-expressed L3, but where we have y, I substituted it with L1. So we can now have 2x positive 9 over 2x. I've made it positive because of, then this now be minus -3 times 5 over 2. It becomes -15 out of 2 is equal to -27. We can group terms. 9 over 2 is 4.5 plus 2, making it 6.5, the value of x. 6.5, the value of x. This equal to -27 plus 15 over 2. 15 over 2 becomes positive on the other side. So that's -19.5. And we remain with x by dividing through by 6.5. This gives us exactly -3. Then the value of y can be expressed. The value of y can be gotten by substituting x in the first equation, y equals to -3 over 2. Instead of x, -3 plus 2 and half plus 2 and half, like that. So this is positive 9 over 2. 9 over 2 plus 5 over 2, giving us exactly 7. So the point where the two lines meet is point -3, 7. Just solve the two equations simultaneously to get their point of intersection. Remember in Form 1, when you plot two lines on the same Cartesian plane, you usually read their point of intersection as the solution to the two simultaneous equations. Then it means if you can manage to solve the simultaneous equations, then the x and y that you get will simply translate to the point of intersection if the lines had been plotted. Did you get that interchange of concepts? Form 2 and Form 1 mixed up. Yeah, that's it. That is it. Very good questions. Very, very good questions. Well thought out paper. Remember to subscribe. Those who are joining late, you're most welcome to this particular program. Shifting Grades is the home of academics. So kindly join our programs. There is even this wonderful discussion whereby we'll be helping the students and learners in junior school and also in secondary schools over the holiday to cover content that will help them in future. Remember, this program shall be happening via Google Meet. Google Meet is a very interactive forum. Learners can ask questions. They can respond to questions. They can raise up their hands to seek clarity. So please, just refer your friends, your brothers and sisters in junior school and also in senior school. The timetable is out. You remember our consultation line? It's already attached here. So kindly reach out to us so that you may know more about our schedules. Thank you. Thank you for being around. Let's continue learning. 19 on transformations. Triangle A prime, B prime, C prime. Drawn is the image of ABC and a negative quarter turn about -1, 0, -1. So we have the description of the rotation there, whereby you're supposed to have the center, and the angle at the direction. On the grid provided below, draw the triangle ABC, whereby the image of ABC has already been provided. So we connect first this image to the center, 0, -1. The center is 0, -1. So this is the center for the enlargement. If that is the center, then, I'm supposed to be having my protractor here to help me work out a few things. Allow me to change this color to blue. So the idea here is we are supposed to join, if it's A prime, we can see it to -2. We join A to the center. Then once you join it to the center, behave like you want to slightly proceed on the other side, so that you say, now for us to get A prime, when the object was brought, because it is a negative quarter turn, that was a clockwise. Negative quarter turn is a clockwise. Now to get back, negative quarter turn means clockwise. That's a clockwise turn. Meaning, for us to get back now, to reverse this, we are supposed now to do a positive quarter turn. So we go now to the anti-clockwise direction. So we measure 90 in the anti-clockwise direction. So using the center, we measure an angle of 90 in the anti-clockwise direction. The reason why I'm going to the anti-clockwise direction is to ensure that I reverse. I reverse. Then I move an equal distance. So standing at the center, I pick the distance to A and I mark it on the opposite side. So that becomes my A original now. So that means A was connected to the center of rotation, then you turn positive 90, you turn negative 90, which is clockwise. That's why for me to get back to A, I have measured 90 in the anti-clockwise. I had to measure it in the anti-clockwise direction. I had to measure 90 in the anti-clockwise because A, to give us A prime, it was measured in the clockwise, and we are reversing now the transformation. That's a technical question. Ladies and gentlemen, you're supposed to be very careful with that one. This one is a high order question. All right. Can we check the other coordinates like B, then later C? If I join B to the center, I join B to the center, then I slightly surpass. I'm supposed to measure 90. I'm supposed to measure 90 in the clockwise direction. Yeah, in the clockwise direction, then I produce. So I measure 90, then I produce now the line. Standing at the center, I pick the distance to B, and I mark it the same distance along this line now where 90 was measured. That becomes our B original. Then finally, we do this for C. We now do this for C. We do this one for C now. We do this one for C. Do it for C. Let's check. We have to connect C to the center of the rotation. C to the center of the rotation. We connect C to the center. We connect C to the center. Then once C is connected to the center, we measure an angle of 90 and we produce the line. We measure an angle of 90 and we produce the line to that other side now. 90 in the anti-clockwise direction. 90 in the anti-clockwise direction. Then now, ladies and gentlemen, you are supposed to stand at the center of this particular rotation. Center of rotation. Then you pick the distance to C prime and you mark it off on the other side so that you get C original. So you see now, we are having all the vertices, meaning that if we join them faithfully using very straight lines, we will get now the original triangle, which was transformed to give us the image. That one requires somebody who knows rotation and also somebody who is free to think, free to reason. Yeah, somebody who is very free to reason. Look at that. Just look at that. So we have gotten now the original triangle, which was rotated. Aha, we have drawn a. Can we check the next question? Roman 2. Look at Roman 2. The question says, A double prime, B double prime, C double prime, the image of triangle A prime, B prime, and reflection line y equals to x minus 1. Look at that mirror line. Y equals to x minus 1. So we can get a small table here, values of x and values of y. When x is a value like 3, y should be x minus 1, so 2. When x is a value like 4, x is a value like 3. When x is 5, y becomes 4. X minus 1 to get y. So 3, 2, 4, 3, 3, 2, 4, 3, you know, 2, 1, like that. So we join the dots. We join the dots. Even with a coordinate on the negative, a coordinate like -1, we'll have to get -2 because we subtract 1, -1 minus 1. So -1, -2. Those are the coordinates. So we can now come up with the mirror line. Mirror line where the triangle has to be reflected. Without a reflection, without a mirror line, you cannot perform a reflection. You cannot perform. That is the line whose name is y equals to x minus 1. Yeah, y equals to x minus 1. That is the mirror line. Now we are supposed to do what? To carry out a reflection. A reflection. For you to reflect, you know that you're supposed to do it. One, the points are supposed to be connected to the mirror line perpendicularly, not just anyhow. You connect perpendicularly. Yeah. Like C has been connected already to the mirror line. Then you pass an equal distance to the opposite side. That is the meaning of reflecting. Reflection happens even in your mirror. Reflection happens in your mirrors. And you know very well that you usually go to the opposite side of the mirror. Opposite side of the mirror. So we are supposed to know that every coordinate should be connected to the mirror line, then we move an equal distance. an equal distance to the opposite side. Equal distance to the opposite side. Therefore, if it's a coordinate like C, as I was saying, you connect C to the mirror line perpendicularly. Perpendicularly, you connect C. Then now you move to the opposite side and you move an equal distance. So standing on the mirror line, pick the distance to C and mark it off so that you get C double prime. We can connect A and to move equal distance. Yeah, connect A and move equal distance. So we connect A perpendicularly, then move an equal distance to the other side. So that A double prime now shall be there. Do the same for B. We connect B to the mirror line, then you move to the opposite side. So when I connect B, then to the opposite side, then I stand on the mirror line, I pick the distance to B, then I mark it off to the opposite side. So this becomes B, second image. Yeah, B, second image, like that. So now we can complete the dots and come up with our triangle. So this is now the reflected. This is now the reflected. Yeah, you see, a rotation. A rotation has occurred. Not a rotation, sorry, a reflection. You connect A to the mirror line, equal distance on the opposite. B to the mirror line, equal distance on the opposite. C to the mirror line, equal distance on the opposite. And the connecting should be perpendicular. You don't just bring B to the mirror line. It should be perpendicular. Yeah, you do it perpendicularly like that. Wow, that's interesting. That's quite interesting. That is quite interesting. Quite interesting. Okay, can we check part B of this question? What have we been told? We are told triangle A triple prime, B triple prime, C triple prime with vertices A triple prime at -2, -5, -5, -5, -7, -2 is the image of triangle double prime under a translation. Part 1, draw the triangle first, then describe the transformation fully, of course, under a transformation. Okay. So let's first plot the coordinates. -2, -5, -2, -5 takes us to this point. That's A triple prime. -5, -5, -5, -5. This is B. -5, -5. Then we have C, -7, 2. -7, -2. -7, -2. C, 1, 2, 3. Third image. Okay, we can join. The first thing is just to draw the triangle. Just to draw it. Just drawing the triangle. Let me check some different color here. A to B, B to C, and back to A, so that we enclose our triangle. We are now having the triangle. We are already carving the triangle. Describe the transformation. Describe the transformation. So what maps this triangle here onto these? One, you ask yourself, one thing that you can see, they are directly congruent, because in case I lift the first one, I can directly bring it onto the second one. They can fit onto one another, equal in size, so it's not an enlargement. Then now that they are directly congruent, we say this, it is not a reflection. With a reflection, we have what we call inverse congruence, or rather opposite congruence. So it's either, we said it's not an enlargement because they are congruent, not an enlargement. And because it's a direct congruence, it's not a reflection, an X there. Therefore, it's either a rotation or a translation. Either a rotation or a translation. With a rotation, we are supposed to identify a center. But when you look at them again, in case you lift the first one, let me call this one. We can call this one 1, then this one 2, then this one 3, then this one 4. So if I lift 3 and I fit in to 4, it shall enter into 4 without having to rotate, without having to twist it through a common angle. Therefore, the triangle has not been rotated. This is likely to be a translation. This one is likely to be a translation. So let's check what is happening to A to become the image of A. What's happening to B to become the image of B? What's happening to C to become the image of C? So let's consider now. Could this be a translation? Could this be a translation? I'm looking for conspicuous color like that. Okay. So from C, I can see along the x-axis, there is a movement of 1 unit. Then along the y, we go down for how many units? From 4 all the way to -2. So we have 4 plus 2, 6. So we are moving to the left 1 unit and downwards 6 units, -1, 6. Are we doing the same for B? We move from B 1 unit towards the left, meaning negative on the x, then downwards all the way to B, the image of B. How many units are those? So from 1 all the way to 5, we shall have 1 unit, then all the way to -5, 5 other units. So it's still 6. So it's still -1, 6. What about A? If we move to the left, it shall be -1 unit, and downwards 6 units, so -6. So, ladies and gentlemen, this one now is proving to be a translation. We first mentioned that it is a translation vector, a translation vector, which is -1, -6. -1, -6. It's my hope that you've seen how we've come up with that translation vector. -1, -6. How is A being mapped to A? Is it the same way B is becoming B? Is it the same way C is becoming C? Alternatively, you can use the approach that we used in number 17, where we said translation plus object should give us image. Then if you use, for instance, a non-translation, XY, then you add to an object, an object like A was negative 1, 1. Negative 1, 1. Negative 1, 1. What about the image? What about the image of A triple prime? It became negative 2, 5. Negative 2, 5. Negative 2, negative 5. Like that. Negative 2, negative 5. Yeah, negative 2, negative 5. So how will you remain with the translation vector? To remain with x, we have negative 2 plus 1. It becomes negative 1. To get y, we have negative 5. We subtract the 1 here. We get negative 6. So the translation vector, negative 1, negative 6. It's common for all of them. It's common throughout. Look at the last question here. The last question of number 19, not the last question of the paper. The last in number 19. This looks like a good question. State any pair of triangles which are directly congruent and oppositely congruent. Oppositely can also be inversely congruent. Remember these, I've already talked about that when I was trying to establish the transformation in part B. For direct congruence, what should have been involved should be a rotation or a translation. So for us to get the answer for part 1, let's look for the pairs where it is either a rotation or a translation that got involved. And just in the previous one, A double prime, B double prime, C double prime, and A triple, B triple, C triple. There was a translation, the one we are just through with discussing. That is one pair which can help you. We also need another pair. We can state another pair, but we just needed one. The examiner just needed one. So that's already enough. You identify the cases where either translation or rotation got involved. Okay, we check another one. Do we have a rotation? Yes. The first one and the second one, it was a rotation. Therefore, you can also state A, B, C, and A prime, B prime, C prime, because it is a rotation that got involved. We have direct congruence. Remember, direct congruence means you can lift one of the triangles and place it directly on the other for the case of translation. And for the case of rotation, if you uniformly rotate the vertices through a common angle, they can fit into the other triangle. Directly, they may not fit, but when you rotate them uniformly through a common angle, they fit onto the other one. Therefore, we have direct congruence. Then in opposite congruence, it should be a reflection. Should be a reflection. So where was a reflection involved in mapping this triangle here to the second image? Therefore, A, B, C, and double prime, there was a rotation, there was a reflection involved there. And hence, the congruence is opposite, or rather, inverse. Thank you, thank you, thank you for following up. Remember to comment, guys. Let's know where you're watching us from. Let's know whether you are learning something in Shifting Grades Online School. Please, let's know. Leave a comment kindly. Drop a comment. Drop a comment. Otherwise, thank you so much for remaining vigilant, for being around even at this crucial time. as you prepare for the national exams. We get to number 20 now. We get to number 20. Number 20 says what? The distance between towns A and B is 180 kilometers. A bus covers the distance at an average speed of X kilometers per hour. Okay. When the bus moves at 18 kilometers per hour faster, it covers, okay, the driver maybe. It covers the distance in 30 minutes less. Calculate the speed X kilometers per hour of the bus. Let's find the value of X. In other words, there is something that we call time, distance, and speed, and we all know how they are related. Speed is the rate of covering distance, so distance over time. When we talk about time, time should be given by distance over speed. Distance over speed. Therefore, we say this, there is a certain common distance of 180. Then there are two speeds here. There are two speeds. Let's say first time taken. The first time taken, we can say this. The time taken covering a distance of 180 at a speed of X. Then this speed can be increased, making us take shorter time. So the time taken is expressed by distance over speed. When we subtract the time taken to cover the same distance, but now using a speed of X plus 18, the time difference between the two times taken. The first time taken, 180 over X. Now, the bus can also use a speed of 18 kilometers faster, making it 180 over the new speed, X plus 18. This now is supposed to give us time difference of 30 minutes. You know 30 minutes means half an hour because it is in kilometers per hour, so we can't use minutes. Should be half. Yeah, so now we are supposed to work out now this particular equation until we get the value of X. Allow me take the LCM, which is X into X plus 18, 2, like that. So we take LCM, divide by X, and we shall remain with 2 multiplied by X plus 18. So 180 is now being multiplied by 2X and 36, like that, minus 180. 180 is now multiplying what? We have this particular LCM divided by the second denominator there. We get X times 2. 2X equals to, when we divide by 2, the LCM divided by 2, we remain with 1 multiplied by X squared plus 18X. Try to open the brackets at that stage. Now we do away with the LCM, we open brackets, we group terms together, we solve for the value of X. 360X plus 180 by 36. This gives us 6480 minus 360X, X squared plus 18. Can we group 18X? Can we group terms together so that we solve all this? You see, 360 cancels the other 360 here. Yeah, when you bring them together, they just cancel out. So we can solve now our equation by talking about X squared plus 18X. Then this becomes a negative 6480 equals to 0. We can use one of the many methods of solving quadratic equations, because it's now quadratic in nature. You can see it's a quadratic equation in nature. So let's solve it using even the quadratic formula. We use the quadratic formula to solve it. It's good we yeah, we solve it using the quadratic. Allow me use the formula. I know there are many ways of solving this, but allow me use the formula, whereby we say we need the value of x to be given by negative b plus or minus negative b. You know, the value at b is already a positive. It's already a positive 18. So we talk about negative 18 now, plus or minus the square of b, 18 minus 4 into a and c, which is negative 6480. Then we divide by 2 multiplied by the value at a, just 2 times 1, making it a 2. We continue solving this. We continue solving this. What is the value of x, ladies and gentlemen, as we continue working out? I'll be having 4 by 6480, because it becomes positive there, plus 18 squared. Then now we carry out square root. I get 162. So negative 18 plus or minus 162, then over 2. The speed of x shall either be 162 minus 18 divided by 2, giving us 72, or x equals to negative 18 minus 162, then we divide by 2. I'm getting negative 90 kilometers per hour. Okay, negative 90. Those are values of x. So as we deal with speed now, the speed cannot be negative as long as the bus was moving. We can settle on a speed of 72 kilometers per hour. As long as this bus was moving, it used a positive speed. So we ignore the negative value of x and work with 72. So the value of x is 72 kilometers per hour. Now we can check part B of this. Now the bus left town A for town B at 7 a.m. 20 minutes later, a tractor left town B for town A using the same route at an average speed of 32 kilometers per hour. Calculate part 1, the time when the two vehicles met. When the two vehicles met. Okay, here we are talking about 7 a.m. 7 a.m. You know, we said there is A and there is B, 180 kilometers apart. By 7 a.m., the bus left town A. But later, 20 minutes later, you know, 20 minutes later means after how long? 20 minutes later, 20 over 60, which is a third an hour. So this time multiplied by the speed of 72 shall give us the distance covered by this bus before the tractor began its journey. We are getting 24 kilometers. Before the tractor began its journey, the bus had already moved. So by 7:20, by 7:20 a.m., this particular bus had already covered 24. The bus had already covered 24 kilometers, meaning that by 7:20, the distance between them was 180 minus 24. 180. I'm using the 180 in the first instruction here. Yeah, so people may get surprised, where is the 180 coming from? Then we get 156. So there was a distance of 156 kilometers by 720. Now, by the time the two vehicles are beginning to move together, I want you to know that now the distance between them is what I shall call the relative distance. 156 kilometers. Then we can talk about relative speed. The speed they use now to bridge the distance between them. One vehicle is, they are approaching one another. One is coming at a speed of 72, another one at a speed of 32. So 72 and 32 should be added. It should be 72 plus 32. That is what you call the approaching speed. They are approaching one another at a speed of 104. So they will cover the distance between them at that speed, meaning that we can get the relative time, whereby we need distance out of relative distance over relative speed. So when I take 156 and I divide by 104, I'm getting 1.5. 1.5 means the 1.5 hours, which is 1 hour, 30 minutes. When we say 0.5 in hours, we talk about 30 minutes because it's half an hour. 1 hour, 30 minutes. So what time is it now? It is from 7:20 when they began moving together. Now they are taking 1 hour, 30 minutes to meet. So it's by 8:50 a.m. the same day when they meet. The same day. So they met the same day at 8:50. Wow, this is a very interesting paper. Very interesting paper. Personally, I like this choice of items. Personally, I like the choice of items. Let's check part 2 of this. The distance of the tractor from town A when the bus arrived at B. The distance of the tractor from town A when the bus arrived at B. So when is the bus going to arrive at B? When is the bus going to arrive at B? When is the bus going to arrive at B? The bus is using a speed of 72 to cover 180. A speed of 72 to cover a distance of 180. So 180 out of 72, 2.5 hours. 2.5 hours. Or rather, 2 hours, 30 minutes. This one can be approached using very many different intelligences. We have such a plural word. You can use very many thinkings to work out this. So 2.5 hours is the time taken by the bus to arrive at B. So by the time the bus is traveling for 2.5 hours, remember the bus traveled 20 minutes before the tractor began its journey. The bus had already traveled 20 minutes before the tractor began its journey, meaning that now, by the time the bus is traveling for 2.5 hours, the tractor will have traveled for 2 hours, 10 minutes, because there are 20 minutes when the tractor had not begun. There are 20 minutes when the tractor had not begun. Therefore, the tractor has traveled for 2 hours and 10 minutes. We can convert it to 2 and 1/6 hours. Yeah, in terms of hours, the tractor has already traveled for 2 and 1/6 hours. because there are some 20 minutes when it is the bus that was traveling. Then 20 minutes later, the tractor began, which means by the time the bus is traveling for 2 hours, 30 minutes, the tractor has only traveled for 2 hours, 10 minutes. What else, or what are we supposed now to do with the 2 hours, 10 minutes? The distance the distance of the tractor from town A. Remember, tractor is moving from B towards A. Therefore, how far is the tractor? How far is the tractor from A? Let's check how far it has already covered from B. So we talk about distance as speed times time. The tractor. Speed times time. Speed times time. So we talk about 21/6 times 32. We are getting 69 1/3. A distance of 69 1/3 kilometers. But this is from B. So from A, the tractor is going to be 180 minus 69 1/3. 180 minus this, we get 110 2/3 kilometers. So this is the total distance the tractor is from town A by the time the bus is arriving at B. I know you can approach it using several other ways, but that is the most convenient approach. That one is the most convenient approach. Proceeding to number 21 now. This is a question on measurements. This is a question on measurements. Let's read the question together. Remember to subscribe, guys. Remember to share. Remember to refer your friends. You might be in Form 4, and this is your last time to revise with our program. We just want to urge you to refer people in the lower levels, just in your school, the friends that you know in your village. Please refer them to the best program ever, Shifting Grades Online School. Okay, 21, a solid, or the solid below comprise of a cylindrical solid and a base, which is a frustum of a pyramid. That one we can see. A frustum from a pyramid. Then we have a cylindrical top at this point. A hemispherical hole is drilled at the top of the cylinder along a dotted line, just as shown. So we have an hemisphere which has been scooped from the top of the cylinder. Radius of the cylinder is 1.8, and the height, and the height is 18. The height is 18. Okay. Given that the original pyramid had slant edge of 32.5, then the length HG is 7, GF 24, just as you can see, BC 4.9, AB 16.8, find to 1DP. So the instruction about 1DP is for all the parts of this question, not just for Roman 1 or for part A. Okay, the total surface area of the solid. The total surface area of the solid. One thing which is very unique about this question, you're supposed to know, you were supposed to understand that then we're also finding the volume. Very uniquely, about volume, when something has been scooped, we subtract its volume. But for surface area, when this hemisphere was scooped from the top of the cylinder, a surface was created. So for surface area, you scoop a certain portion, you create an area. But for volume, you have subtracted material. So we subtract for volume, but we add for surface area. That's a technical bit of the same. A very technical bit of the same. You're supposed to be very aware of such instructions. Okay, so we work it slowly until we are there. I know it's a very involving question, very, very much involving, but we will finish it very soon, sooner or later. So let's begin. I will use all the space provided alongside the question and also below the question. Okay. We can get the volumes bit by bit. Let's begin with the cylindrical top, whereby for the cylinder, we have to subtract the hemisphere. We subtract the hemisphere. So for the cylinder, we talk about cross-section, pi r squared. Have we been given the pi to use? Given that blah blah. The pi has not been provided for us. So allow me choose 22/7. That's pi. A radius of 1.8 squared times weight. I was almost going to volume first. Let me find surface area first, please. I almost went for surface area. So for cylinder, we first need 2 pi r multiplied by h. 2 times pi times 2 pi r h, or pi dh. 2 pi r times h, which is 18. That is the surface. Then we will also add the hemisphere which was created. This is the curved surface. Then we also add the hemisphere that got created. Surface area of an hemisphere, remember it will not have the top now because it was scooped. So surface area of an hemisphere should be half of a pi. You know, the whole sphere is given by 4 pi r squared. 4 pi r squared. Now that it is half, we divide by 2. So it will be 2 pi r squared. 2 pi r squared, making it 2 pi r squared. So with the cylinder part, what are we going to get? The cylinder itself, the curved part of the cylinder, pi r times 2 times 18. This is giving me 203.7 plus 2 pi r squared. We get 20.4. So 20.4 plus 203.7, giving us exactly 224.1. 224.1 square centimeters. So we are done with the cylindrical top. Let's get now to the base, which is a hemispherical. Let me approach it this way, assuming that there is the original Assuming that there is the original pyramid from which a portion was cut off for us to remain with this particular solid or the frustum, then we will say that original slanting edge is 32. Original slanting edge is 32.5. Okay. What about slanting edge of the remaining pyramid or the cone that was cut? That one is not provided. That one is not provided, but there are a few things that we can relate and know. Yeah, there are a few things that we can relate and know what is happening. Remember that all these are linear measurements. And if they are linear measurements, then we can know. We have the ratios. We have their ratios. Then we will be able to say the following, that we'll be able to say the following. When I use the bases here, 24 and 16.8, or 7 and 4.9, there are a few things that we can conclude. One is that the linear scale factor is 24 out of 16.5.8. 16.8. 24 out of 16.8. This is a 1 and 3 over 7. This is 1 and 3 over 7. What about 7 out of 4.9? 1 and 3 over 7. We get the same. So 1 and 3 over 7. 1 and 3 over 7 needs to be written as 10 over 7. Yeah, the ratio is 10 out of 7. 10 out of 7. The smaller, the bigger one over the smaller one is 10 over 7. So with that, we can manage what we remain with now. We can manage this one and say, if we are talking about original vertical height, then we can let the one that was cut to be having a slanting height of x, so that the remaining one, you see, so we say this, when we take the original 32.5 and we divide by x, the one that was cut, the smaller one, we're supposed to get the same ratio, 10 over 7, because they are all linear measurements. So what is x? The slanting height of the triangle that was cut. We need to take 32.5 and we divide it by 10 over 7. We get 22.75, or simply 10x equals 2. So 32.5 multiplied by 7, but divided now by 10. 22.75. So the slanting height that was cut off is 22.75. That way. So we need to consider now original slanting edge minus the smaller slanting edge that was cut for us to get the surface of the frustum that remained. Look at it this way. Look at it this way. Actually, when frustum is from a pyramid and the pyramid is rectangular, it is usually tougher than when it is square, and the square is usually tougher when it is conical. from a cone, it becomes the easiest frustum to operate. Let's look at this. Let's look at this, ladies and gentlemen. Let us look at these. Now, this is what we're having. I will choose one face first, then I will get to the other. So I'll start with the one that has a base of 24. The one that has a base of 24. Then we will still go to the other one with a base of 7. So this is what we're having. This is 24. Then this is 16.8. Then the standing edge is 32.5. Landing edge 32.5, and the smaller edge here, the smallest landing edge is 22.75. 22.75 here, like that. So with that now, we can find the vertical height through these spaces. The vertical height through this space. Vertical height here, whereby we need the 12 on this side. Yeah, and 32.4. So height shall be, we talk about 32.5 squared minus 12 squared. This gives us, when we take square root, this Pythagoras theorem, we get 30.2 centimeters. What about this other one? Whereby 16.8 can also be divided by 2 to give us 8.4. So we have 8.4 here. So we need 22.5.75 squared minus 8.4 squared. Then the square root, 21.14. So the landing height there is 21.14 centimeters, okay? 21.14 centimeters. So allow me now to talk about the slanting faces, which is a ABGF, and the other one on the opposite side, DCHE. Yeah. So we talk about half times base times height. Half times a base of 24 times a height of 30.2. Then we subtract half times a base of 16.8 times a height of 21.14. And we subtract. Then after subtracting now, we shall be multiplying by 2 such faces. Yeah, we multiply by 2 such faces. So what are we having here? What are we having here? This is going to be half multiplied by 24 multiplied by 30.2 minus half multiplied by 16.8 multiplied by 21.14. This gives us 184.824 times 2. We get 369. Point 0.6. 369.6 square centimeters. That is for the 2 phases. That is for the 2 phases. Can we talk now about the other phase? Can we talk about the other phase? Guys, remember to subscribe to our platform. Remember to share the link with friends. Yeah, just remember to invite friends to this powerful lesson. Now, when we consider the others now, one thing that you're supposed to notice is that we are now having, let me draw it again. We are having 4.9. We are having 7. We are having 32 points. We are having 32.5 as the original and 22.75 as the smaller slanting edge. So we can also get the verticals through here. The verticals through here, whereby we need the 3.5 here. So that height becomes what? I again apply Pythagoras theorem to 32.5 squared minus 3.5 also squared. Then I take square root 32.31, 32.3. Then the smaller h with 4.9 over 2, that is 2.25, 2.45. So I need 22.5 squared, 22.75 squared, minus 2.45 also squared. Then I take square root, I'll get 22.6. So now we can talk about now the bigger triangle minus the smaller one. So half multiplied by a base of 7, half times a base of 7 times the height of 32.3 times, yeah, that's the base times height. Then we can now subtract. We can now subtract minus half times a base of 4.9 a base of 4.9, so times a base of 4.9 multiplied by, now with 4.9, we multiply by the vertical height of 22.6. The vertical height of 22.6. 22.6. Let me check the mark pen. Something is not happening. Yes. Yeah, we have it here now. 22.6. Then after that now, we multiply everything by 2. So let's check. Half by 7 by 32.3. Then minus half multiplied by 4.9 times 22.6. Then this has to be multiplied by 2 such surfaces. 2 such surfaces, 115.4. Yeah. So now we have the slanting faces already obtained. Original triangle minus smaller triangle, we multiply by 2 such faces. So these faces are 2, and also the ones like this one are also 2. So that's why I'm multiplying by 2 after finding 1. Then which areas have we not found? We've not found the base and also the top of the frustum. So the base of the frustum, 24 by 7. Now that it's just rectangular, 24 by 7, giving us 168. 168 square centimeters. Then the top should be 16.8 by 4.9. Then we subtract. On the top now, we don't have the whole rectangle there. There is the cylinder resting. So we subtract the circle there. The circle resting there should be subtracted. Radius 1.8. We subtract the circle resting there. So 22 over 7 by 1.8 squared. 1.8 squared. So for the top, we should have 16.8 times 4.9 minus 22 over 7, 1.8 squared. This gives us exactly 72.1. So I think we've now taken into account all the surfaces making up this particular solid, and we can now proceed to get the total surface area. So we can add, we are having 72.1 plus 168 plus 115.4 plus 369.6 plus, we talked about this, 224.1. Then now we need the total. So let's add that. 72.1 plus 168 plus 115.4 plus 369.6 plus 224.1. This is now 949.2 square centimeters. So that is the surface area. Now the total surface area. We've taken into account all these surfaces. Yeah, it's a very good question. It's a very good question. Very good question. Very serious question. Yeah, so those who are following up, remember to subscribe, remember to share so that you may continue getting more. We also need the volume of the same solid. Volume of the same solid. Volume of the same solid, and I hope now it will be quicker and easier. Allow me clear up this space so that we have simple work in analyzing the volume. See, yeah, any sweep. So that now we discuss the volume. Yes. And guys, are you still remembering our very serious programs here for high school and also for junior school? The timetable is out, a very considerate timetable with enough time for changeover from one subject to the next, with sufficient changeover time, with well-equipped teachers. Facilitators will be top-notch. Let me tell you, I've gotten you the best lineup of teachers. I have gotten you the best lineup of teachers, and you shall not regret trying shifting grades. This is just the best. Shifting grades is just the best. So kindly feel much invited, whether you are in junior school, senior school, whether it is your brother, your sister, your neighbors, your siblings, your friends, your cousins, just invite them. Just invite them to a very powerful program here. Nobody has ever regretted by partnering with shifting grades. Nobody has ever regretted partnering with shifting grades. You will always find a reason to come back. When you interact with shifting grades, you shall always find a reason to come back. You shall always find a reason to come back. Okay. Let's now check. We need volume, ladies and gentlemen. So for the cylindrical part, as I said, with the volume, we have to subtract because some material is getting scooped here. So we talk about now for the cylinder. We talk about pi r squared times height. Then we subtract the hemisphere. You know, for an hemisphere, for a sphere, it's 4/3 pi r power 3. Now that this is a hemisphere, we multiply by half and it becomes 2/3 pi r power 3, like that. So we can now check the volume for the hemispherical part. So let me start with 22/7 multiplied by 1.8 squared multiplied by 18. Then I subtract 2/3 multiplied by 22/7 multiplied by 1.8 power 3. Sorry. 22/7 by 1.8 squared times 18, then minus 2/3 multiplied by 22/7 multiplied by 1.8 power 3. This is going to be exactly 171.1 centimeters power 3, rather centimeters cubed. Okay, with this now, let's talk about the other part now. The other part now requires a serious analysis again, serious diagnosis, a very serious analysis, a very serious analysis. Yeah, this is the original pyramid. Remember, we are having slanting heights. We are having slanting height. So this means we can now get vertical heights. We now start by getting the vertical heights. Yeah. So if I pursue the pyramid like that through the center, and I'm having 32.5, I can get the original vertical height. First, I need to use 24 and 7 to get FH. 24 squared plus 7 squared, then we take square root. So FH is 25. When we divide it by 2, ladies and gentlemen, I'm getting 12.5. 12.5, then 12.5 here. At 12.5, 12.5 like that. 12.5, 12.5. So with 12.5, I'll be able now to use it together with 32.5 so that I get the vertical height, capital H. Vertical height like that. So 32.5 squared minus 12.5 also squared. And now I take square root. 32.5 squared minus 12.5 also squared. Then I take square root. This is exactly 30. Exactly 30 centimeters. So the vertical height is exactly 30 centimeters. The other one, I don't even have to use Pythagoras theorem and all that. I don't have to use Pythagoras theorem, though when I use Pythagoras theorem, I will still get it. You can still use Pythagoras theorem. You can still use the relations, the similarity and enlargements. Or we can proceed to, let me relate and say this. If I take 30 and I divide by the small h, I should be able to get the 10 over 7. Yeah, the 10 over 7. I should be able to get the 10 over 7 like that. I should be able to get the 10 over 7. Therefore, can we say that 10h equals to 30 by 7? So that I divide by the 10, and I get the smaller h as 21 centimeters. So the smaller vertical height is 21. The smaller vertical height is 21. So we can now talk about volume. You know, we are having 30 and 21. How do we get volume? Volume requires a third base area times vertical height, a third base area times height, minus a third, the other base area, which is 16.8 by 4.9, times a vertical height of 21, like that. Yeah, 24 by 7, 16.8 by 4.9, the vertical heights. So volume for this part shall be equal to, we have a third multiplied by 24, multiplied by 7, multiplied by 30. Then I subtract a third multiplied by 16.8, multiplied by 4.9, multiplied by 21. This gives me exactly 1103.76, or rather 0.8 centimeters power 3. So now we have volume of the frustum part, and also volume of the cylindrical part is already obtained. So now with that, we can add 171.1 total volume. Total volume shall be equal to 1103.8 plus 171.1 plus 171.1. So we are getting 1274.9. 1274.9 centimeters power 3. Centimeters power 3. That's a very good question. A very good question. Thought-provoking, well-involving, well thought out. It's just a great question. Just a great question. Please ensure that you are keenly following up so that later when you be alone in that circumcision center, when you be alone, you will know how to maneuver. But of course, if you've been consistent with our programs, it's like you've seen all the difficult questions so far. There is nothing that can threaten you. Nothing that can threaten a serious person like you, a serious follower of shifting grades cannot be terrorized by very simple questions like these ones. Yeah, like that. Can we proceed? Yes, we can. We can proceed. We can proceed. Twenty-one, 22 now. Yeah, number 22 now. Now the figure below represents two neighboring plots with QR as their common boundary. So you have a common border there, 20 centimeters QR. Find to 2dp. Again, the instructions about 2dp are for the whole question. It's not just for part A. So find to 2dp the length of the border PQ. The border PQ. PQ is not identified. Can we consider the triangle PQR and say this length is a small letter r, this one is a small letter q, then this is a small letter p. So that according to what you call the cosine rule, when we take r squared, it should be the same as q squared p squared minus 2 q p, the cosine of the angle at r, like that. So with that statement of the cosine rule, we can apply it. R squared equals to 35 squared plus 20 squared minus 2, 35 by 20, the cosine of the angle at R, 63. So R power 2 equals to, let me compute everything here. I need to talk about 35 squared plus 20 squared, then minus 2 multiplied by 35 by 20, the cosine of 63. This gives me 989. 989.41. 989.41. So that R now equals to, I compute the square root now, 31.45. 31.45. These are meters, not centimeters. Yeah, these are meters, not centimeters. Meters, not centimeters. Yeah. Just the cosine rule, 31.45. That's 1.45. Part 2. The angle RQS. RQS. The angle RQS. The angle at that point. Okay, that one might be very quick, considering that PS is a straight line. The angle here shall be 180 minus 63, giving us 117. So for us to get the angle at Q, considering the triangle now, the angle at Q be given by 180 minus 117 and also 36. Is it 36? Yeah, 36 and 117 subtracted from 180. So the angle at Q shall be 180 minus 117 plus 36. This gives us 27. That gives us 27, like that. The angle is exactly 27, like that. We proceed again to check the length of the boundary, RS, the border, RS. Where is RS? RS is just the length here. This one now can be very easy because already we know these angles. We have 27. We know all the angles. So we can even apply the cosine rule. This is 20. The opposite angle is 36. You know the cosine rule says what? The sine rule says that. This is a, we know we're using a different triangle now. So with triangle QRS, we can call this one Q. We can call this length R. We can call this one S. So when we take R out of the sine of the angle at R, we get the same as Q. Out of the sine of the angle at Q, we take again S out of the sine of the angle at S, like that. That is the sine rule. So we pick one ratio which is complete so that we may relate it with Q. Q over sine 27. Q over sine 27. Q out of the sine of 27 should be equal to 20 meters out of the sine of the opposite angle, which is 36. 20, 36, yeah. The side S and the opposite angle S, like that. So we can find Q. And find Q very quickly by multiplying 20 sine 27 out of the sine of 36. This gives us 15.45. 15.45 meters. Then finally, something else that we also need is the area. Oh, we've been taught to 2dp. To 2dp. So this is not just 27, should be 27.00 meters. Yeah, imagine losing that mark. 0.00 degrees. Everything to 2dp. Find to 2dp. Don't leave any value as an exact answer. Please introduce the 2dp. Please introduce the 2dp like that. Introduce the 2dp like that. Oh, a very good question. Are we now looking at part D? Let's check part D of this question. Let us check part D of this. Area of the triangle QRS. 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 So we can apply several approaches. Do we know the length Q? The length Q has been found, RS 15.45. 15.45. So we can consider two sides and the angle between them. Half AB sine beta. Yeah, half AB sine beta. So half 20, 15.45. Area equals to half AB, the sine of beta, half 20, 15.45, the sine of 117. We just consider the angle between the two sides that you've used. So when I compute these, I will arrive at the answer very quickly. 0.5 by 20 by 15.45, the sine of 117. This gives us 137.66. 137.66. square meters. Wow, very interesting, very, very interesting. At number 23 now, as we continue winding up. At number 23. At number 23 now. The marks of students in a certain class were recorded as, you can see the marks there in classes. You can see the marks in classes. Then not in classes, sorry, just recorded in this particular table. Then we are told in part A, ending with the highest mark and using a class interval of 5, make a frequency distribution table for the data. One thing that we're supposed to be sure about is that we don't know the number of classes, but you know the last class should end with the highest mark. Therefore, when the last class has ended with the highest mark, it doesn't mean that the first one starts with the lowest. Not really. It is the intervals that will align us to the classes. So we even don't know the number of classes that will be there, but you can use the range to know anyway. So allow me start from the highest class, which of course cannot be stated first, should be stated last. So I love the class there. Then later I'll be tallying and finally compiling the frequencies. You can have the class here. You can have the tallying column. Then we compile the frequency there. So I end with the highest score. Which is the highest score here? Ending with the highest mark. Which is the highest mark? These are marks scored by certain students. So the highest mark, I can see an 89. We have 90s. Looking for a learner with 90, a student with 90. And from these marks, I don't see any 90. So meaning that 89 is the highest. So I'm ending with 89, ladies and gentlemen. So to use an interval of 5, it means I must have started from 85. Yeah, 84.5 minus 89.5 gives an interval of 5. So 85. So from 85, let me write well. From 85 to 89, that's a class width of 5. When you subtract the boundaries, 89.5 and 84.5, you get 5. Then the other one should now be ending with 84 from exactly 80, 79, from 75, 70, 74, from exactly 70, 69, from 65, 64, from exactly 60, 64 from exactly 60. I must accommodate up to the list. Remember, I must accommodate up to the list. I can see 51. What is the list score here? This is a very good class. In a certain class, I can see 51. Do I have 40s? Oh, there is a 48 here. I'm looking for the list. 48. There's a 49 here. We don't have 30s. We don't have below 48. Okay. So let's stick to that. Let's now stick to that. So we should be having 59 from 55, 54 from 50, meaning that we will need another class here. We shall need another class. We shall need another class all the way to 49 from 45. Now, I don't think we have a lower mark than that now. We don't have a lower mark than that. So with this now, you will allow me to partition the classes very well so that we do something efficient. To improve our accuracy, allow me partition the classes like that so that each class has its own row. Now we are through with coming up with the classes. The next thing should be now placing we place every mark to the class where it belongs. Allow me use red for that assignment. Allow me use red. So we mark a score, then we take it to the class where it belongs. We mark a score, then we take it to the class where it belongs. Yeah, thank you guys for staying around until this late. Thank you, thank you, thank you, thank you, thank you for joining us in today's classes. You are the best, you guys, and we are wishing you all the best. We start with 48, and the class is here. We go to 62, and the class is here. We go to 56, and the class is here. We go to 58, and the class is here. We go to exactly 70, the class is here. 69, here. 72, here. 83, here. 59, here. 64, the class is here. Go to 59, there's the class. 51, here. 67, here. 68, this class. 79, here. We have 82, sorry, 82 is here. 70, this class. 68, it's 68, this is the class. 52, here. 51, same class. Okay. 89, this is the class. 72, here. 68, you know they are already 4, so we wrap them like that. 77, here. 64 is the class. 70, we wrap them, they are already 4. 75, here, 71 here, 58, yeah, already 4, we wrap them, 57, same class, 79 here, yeah, 69, there is the class, 80, 80, we bring it here, 62, we mark there, 73, we mark here, 68, we bring it here, 69, we bring it here, 59, here, so we are trying to check something here. I hope the mark for 59 is well captured. You know, we try to mark such that we avoid marking twice. So this was the mark for 59. Then we check 61. They are ready for, we wrap 54. 7, we wrap 59, 61, 68, 64, 69, we wrap again, 49, 69, 64, 62. Wow, that's a very good distribution. So now we can go to the values of f. With the values of f, we start with, we can start with only 2, then this is 4, then this is 5 plus 3, 8, this is 5 plus 4, 9, this is 5, 5 and 1, so 11, this is 5 and 2, 5 and 2 should give us 7, this is exactly 5, this is 3, and this is exactly 1. Yeah, that's the distribution of the data. That one is the distribution of the data. So the confusion that would have arrived is a student thinking that ending with the highest mark also means starting with the lowest. Starting with the lowest. Yeah. Starting with the lowest, like that. So it doesn't mean the same. It means the arrangement should start with the highest mark. So we began at 89 upwards until the class that has 44 to 49. So somebody would have started maybe with 48 or such a thing. Part B, we are told to estimate the median. To estimate the median. Estimate the median. Estimate the median. You know that median is given by lower boundary of the median class plus n out of 2 minus cumulative frequency before divided by frequency, everything raised to, or everything multiplied by the length of the class. So with this now, the first thing to do here is to identify median class. Median class is the class that contains the total frequency. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's around 50. So 50 over 2. But anyway, we can add up and see whether they are 50. So let me come up with what you call the CF column. Let me come up with the CF column. CF, whereby we start with 2, then 2 plus 4, we go to 6. 6 plus 8, we go to 14. 14 plus 9, we go to 23. 23 plus 11, 34. 34 plus 7, this is going to be 41. Then 46 after adding 5, then 49, and finally 50. Yeah, they are totaling to 50. So can we start with 50 over 2 now? Total over 2, we get 25. Then we ask ourselves, where is 25 lying? Where is 25 lying according to the CF? Where does 25 lie according to the CF? So according to the CF, 2, 6, 4, 14, 23, 25 lies in this class, because previously we've not yet talked about 25 or a value greater than 25. So the median class is 65 to 69. So that is the class which will help us now with whatever should be substituted in this formula. Lower boundary should be 65 plus 64 over 2. For you to get lower class boundary, you take the lower limit plus the previous upper limit and you divide by 2. So 65 plus 64 over 2, you get 64.5. Plus 50 over 2 minus CF just before the class. Cumulative frequency before this class is 23. Then out of frequency of the class, which is 11, multiplied by the class length. We were taught to use class intervals of 5. So I hope the class is having an interval of 5. 25 minus 23, we get 2, multiplied by 5 over 11. 5 over 11, this will give us 0.909. Now when we add 64.5, we get 65.41. 65.41. So that is the estimated median. That is the estimate of the median. The estimate of the median. Very good. A very good question. Yeah, thank you. Thank you. Thank you for following. Guys, remember to subscribe. Remember also to share so that you may invite your friends to these powerful lessons. Yeah. To these powerful lessons. Let's now check the rest of the questions that remain from this part. After estimating median in part B, we are proceeding to represent the data using a frequency polygon. You are supposed to know that for every statistical graph, there is what should be plotted for it to be obtained. For instance, when we are talking about a frequency polygon, we know that we need frequency against midpoints of a class. Frequency against midpoints. Then something else that we are supposed to know is that apart from frequency against midpoints, the other thing that you're supposed to know is that if it is a histogram, there are 2 types of histograms. When class intervals are equal, like in this data, we plot what we call the frequency against the boundaries for you to get the verse. Then something else that you're supposed to know is that for you to come up with what we call a histogram, and class intervals are not equal. Class intervals are not equal, ladies and gentlemen. You are supposed to plot frequency density against the boundaries. Frequency density against the boundaries. And frequency density is given by frequency over class width. Therefore, we need midpoints. So we can establish a column for the midpoints, midpoint X, so that we plot. We have to plot F against midpoints X. So let's come up with X. Let's come up with X, the midpoints of every class. 45 to 49. Then we divide by 2. We add and divide by 2. So 47 is the first midpoint. The second midpoint with 50 and 54 shall be 52. Then 57, 62, 67, 72, 77, 82, 87. So we have the midpoints. So to get what we are calling, the frequency polygon now, these are the midpoints that we are plotting against their frequencies. I want to mention something that it's good for you to assume. It's good for you to assume a midpoint before the first midpoint that was provided. You assume a midpoint before the first provided midpoint. A midpoint before the first provided midpoint. So frequencies are ranging from the least one is 1 all the way to 12 to 11. So we don't have 11 classes here. Even if we have them, we shall strain. So you don't have to strain. You don't have to overstrain. So for you not to overstrain, then you're supposed to use values like intervals like 2, 4, 6, 8, 10, 12. Yeah, those are good intervals. Then now the midpoints, whereby the first midpoint is a 47. Assume a midpoint of 42 according to these intervals. A midpoint of 42. Then assume a midpoint of 42. A midpoint of 42. Then you bring it to be the first one now. A midpoint of 42. Then from 42 now you go to 47, 52, then you go to 57, then we have 62, 67, 72, 77, 82, 87, 92, like that. So these are the midpoints. So we have plotted midpoints X. So the midpoints X. Yeah, midpoint X. Then here we plot the frequencies. Frequency against midpoints. The first frequency and midpoint, we have 2 and 47. 2 and 47, allow me plot using some blue. The next is The next is 4 and 52. 52 and 4. After 4, we go to 8. We go to 8. After 8, we go to 9, then 11. 9 in between 8 and 10, then 11. 11 is in between 10 and 12. After 11, we can talk about 7 and 5. After 11, we go to 7, then 5. Mhm. Yeah, so that is it. We are almost concluding. Allow me check something here. Let me check what is happening. Let me check something here. Something is happening with the document. Something is happening with the document, but we are almost getting there. We are almost getting there. Sorry for the interruption. Oh yeah. Sorry for that interruption. Maybe the system wanted you to remember this program. Just look at that. Just look at this wonderful poster. Look at this wonderful timetable. You can't afford to miss. You cannot afford to miss. So kindly join us for the wonderful classes. We were now somewhere here plotting, but we were interrupted. So the midpoint of 77 goes with a frequency of 7, then 3 and 1. So 3 and finally 1. So after you've plotted that, you join using very straight lines, not curves, very sharp lines, every midpoint to the subsequent one. Every midpoint to this subsequent one. Every midpoint to this subsequent one. Every midpoint to the subsequent midpoint, like that. Every midpoint to the subsequent. Using very straight lines, not curves, straight lines. Straight lines and not curves. No, there is a mistake somewhere. Sorry. Let's check these. Let's check this one very carefully. Let's check this one very carefully. Very carefully, we'll check it. Let's analyze it very carefully. You discover that there is a certain midpoint that we skipped. There is a certain midpoint that we skipped. There's a certain midpoint there that I'm trying to rectify. Is a midpoint that I'm trying to rectify at that point. After 7, we were to go to 5. And 5 should go with 82 point. So 5 should be here. So that after that, we now talk about 1. Yeah. we talk about one at that point. Then now we connect using the straight lines. We connect using the straight line, we bring it there. Then after you've connected all the coordinates, now you're supposed to anchor it in a previous midpoint. So you start there. And here, you assume a midpoint after all the classes. Then you drop it there. So you must anchor your frequency polygon on the x-axis. You must anchor your frequency polygon on the x-axis like that. After dropping it like that to the x-axis, you're now through. Then you go to the last question. Using the frequency polygon above, estimate the mean. For you to get the mean, remember we usually check midpoint times frequency. Then you divide by total frequency. So every midpoint times the frequency. You use the coordinates that you've plotted. Now I'm assuming you had a plotted frequency polygon. Then you are told to estimate mean. You know this one you have an idea because you're the one plotting it. But now assuming it had been drawn this way, the examiner tells you crazily to determine the mean from this particular graph. So you're supposed to know that this is a midpoint multiplied by the frequency. So 47 multiplied by 2. You go to the next, because you're supposed to add them. 52 times 4. You go to the next. 57 should be multiplied by 8. You go to the next. 62 should multiply 11. 62 should multiply 11. Then you go to the next. 67 to multiply. 62 should multiply 9. 62 should multiply 9. Then 67 is the one now to multiply 11. Then 72 to multiply 7. 72 to multiply 7. Then 77 to multiply 77 by 5. The next one is 82 times 3. 82 to multiply 3. Then finally 7 to multiply 1. 7 to multiply 1. Then after you've added all of them, so you've added all of them, now you divide by 50. Yeah, after you've added all of them, you divide by 50. So 47 by 2 plus 47 by 2, 52 by 4 plus 57 by 8 plus 62. 62 goes by 11. No, 62 by 9. Then 72 by 11. Then you check something here. 67 by 11. 72 by 7 plus 77 by 5 plus 82 by 3 plus 87 times 1, getting 3275, then over 50. We divide this by 50 and I'm getting 65.5. That is now the mean for this particular class. That is the estimated mean from the histogram, from the frequency polygon. It's a very good question. It's a very good question. But basically, make sure that given a question like this, you can prepare the frequency distribution table accurately. After that, then be sure to be able to plot some basic graphs like histogram, frequency polygon, like that. Then finally, we have number 24 now. We are winding up now. Number 24. Now, the displacement S of a particle is given by the function there. T is seconds, time in seconds. Find part A, the time when the particle is momentarily at rest. When the particle is momentarily at rest, it should be having a velocity of 0. And therefore, we are supposed, in this case now, to first of all, find the velocity function. Therefore, velocity function is given by the differentiated function of displacement with respect to time. So for us to get velocity function, we need to differentiate displacement with respect to time. This is equal to, this becomes 8 plus 6, and t is now power 1. We drop 2 to multiply 3. Then here we drop 3 to multiply 2/3, making it just 2, and t is now squared. So we have differentiated the function, and now we are having the velocity function. So when it is at momentarily at rest, we are supposed to say that this is equal to 0. So 2t, I'm starting with 2t. Velocity function, I'm starting with 2t. Then minus 60 minus 8, we remain with a 0 here. We're just arranging them. So we can now solve it. We can now solve for the value of t. When is the particle momentarily at rest? When is the particle momentarily at rest? When the velocity function equals a 0. When velocity function equals a 0, the particle is momentarily at rest. So we solve this. And we use a product of, I'm trying to use the factorization method, A times C, which is negative 4 by 1, then sum, negative 3. Which factors, which when multiplied, they give us negative 4, and when added, negative 3. Is it negative 4 and positive 1? Is it negative 4 and positive 1? Yes. Negative 4 and positive 1. Meaning that now we can just express t squared. Then instead of minus 3, we have minus 4 and a positive 1. Minus 4 and positive 1. Then minus 4 equals to 0. From the first two terms, we can factor out t. There remains t minus 4. Then we factor out 1 in the last two, t minus 4, giving us a 0. So t plus 1, and from the brackets we have t minus 4 equals to 0, will enable us to say that the value of t is either positive 4 or the value of t is negative 1. And you see, time cannot be negative. So when the particle was momentarily at rest, it's when time was 4 seconds. Yeah, the particle will be momentarily at rest when time equals to 4 seconds. Then we check part B of the same. Part B of the same, the displacement when it comes to rest momentarily. So now we go to the displacement function now. The time it rests momentarily is at 4 seconds. So what displacement has it covered? We go to the displacement function, 8t plus 3t squared minus 2/3 t power 3. The 2/3 t power 3 is that. Then you now compute. It's a very easy question. A very easy question at that point. So 8/4 plus 3 into 4, and 4 has been squared, minus, minus 2/3 into 4 power 3. This is giving me 37 1/3. A displacement of 37 1/3 meters. That's a displacement 37 1/3 meters. Part C. We are told to calculate the initial acceleration. Initial acceleration means acceleration when t is 0. When it was just beginning its motion, t was 0. So what is acceleration function first? For us to get acceleration function, we need to differentiate velocity with respect to time. So where is velocity function first? The velocity function is somewhere here. So when we differentiate this, we shall get 8 becomes a 0. So we start with 6. 6 minus 4t. Acceleration function equals to 6 minus 4, the value of t. That's the acceleration function. Then we need the value of acceleration when t was 0. That is the meaning of initial acceleration. Acceleration when time was 0. So we get 6 meters per second squared. 6 meters per second squared. And finally, what are we handling? Finally, what are we solving? We are solving the maximum velocity attained. Maximum velocity attained. At maximum velocity, at velocity maximum, this particle has fully accelerated. This particle is no longer accelerating. So at maximum velocity, acceleration should be 0. So acceleration function should first be equated to 0 so that we know the value of t. The value of t when acceleration is 0. And this is a 6/4, which is 3/2, or other 1.5, or 1.5. So at 1.5, the particle is fully accelerated, meaning that it has attained maximum velocity. When it stops accelerating, it has attained maximum speed. So now the value of speed shall be equal to, we go to the velocity function, 8 plus 16. 8 plus 16. Minus 2t squared. 2t squared. So this particular velocity, which is maximum, shall be given by, this is 8 plus 9 because of 18 over 2. Minus, we can talk about 2 multiplied by 9. 2 multiplied by 9. Then the other one is a 4. So 18 over 4 minus 18 over 4. This is going to be 12.5 meters per second, because it is a velocity that we are finding. That is the full paper, fully discussed. Remember our programs here. Please invite your brothers and sisters. Let them enroll to our serious platform here. Let them get the best from the best. Otherwise, thank you so much. Our consultation line is already attached here. 0704 15 33 66. Thank you so much for following. We wish you success. See you another time.